All right, so this we're gonna talk about inverse function and logarithms. This first one is just gonna be talking about inverse functions. So to understand about inverse functions, we have to understand this definition of one-to-one. So a one-to-one function is a function f of x is one-to-one on domain D if f of x sub 1 does not equal f of x sub 2 whenever x sub 1 does not equal x sub 2 in the domain. Now, that's a lot of wording to say that your y's cannot be the same value for any values of x that are different, okay? So each x in your domain is going to give you a different y, okay? One value to x goes to one value of y. So one value in your domain goes to one value in your range, and one value of your range only has one value that goes to it, all right? So we're going to talk about the horizontal line test for one-to-one functions. And this is a way that if we see a graph, we can determine if that graph is one-to-one by doing the horizontal line test. So a function y equals f of x is one-to-one if and only if its graph intersects each horizontal line at most once. So here we have two graphs. And the horizontal line test is if I were to draw every single horizontal line, I can only intersect that graph at once. If I intersect the graph more than once for any one of these, it's not one-to-one. So here, this is 1-to-1. Okay, on the second one, I may have some horizontal lines up here and down here that only intersected once. But if I have a horizontal line right here, it's going to intersect that more than once. So even though this is a function, it is not one-to-one, okay? So hopefully you will remember that. We're looking at for every x, there's only one y. For every y, there's only one x. So inverse function. Suppose that f is a one-to-one function on a domain D with range R. The inverse function, f of -1, is defined by this formula here. F inverse of b equals a if f of a equals b. The domain of the inverse of f is R, and the range of f inverse is the domain. Now, what this is saying is that here, these can work back to what we're getting at, okay? So notice here what I did is I plugged in A and I got B. So if I take B and I plug it in my inverse, I get back to my original input of A, okay, and vice versa. So that tells me that these are inverses. The range here, so the range of your original function becomes your input or your domain of your inverse. And the domain of our original function becomes our range, okay? So here, we have this function here, 1, -3, 2, -4, 3, 6, 4, 8. This is our original function. Now our inverse is going to take those values and flip them. So I'm going to go -3, 1, -4, 2, 6, 3, and 8, 4. So this is my inverse. So if I were to come here and pick a value, and let's say I pick a value of 2. So I pick 2, I get -4. I take that -4, I plug it in here, -4, 2, I got back to my original input, they're inverses. So the last thing we're going to kind of do with this is we're just going to talk real quick about finding an inverse. And then we'll come back and talk about logarithms. So when I'm finding an inverse here, what I'm going to do is, remember my domain and range switched. So what I'm going to do is I'm simply going to interchange my x and y becomes x and x becomes y, and then solve for my new y. So this becomes x equals 1/2 y plus 1, and now I'm going to solve for this y. So the first thing I'm going to do is I'm going to subtract off 1. Subtract 1. X minus 1 equals 1/2 y. I'm now going to multiply by 2. And I get 2x minus 2 equals y. There's my inverse. I'm going to put a little -1 up there to let me know that this is the inverse here. Okay? And that's why a lot of times we'll use f of x at the end here. We'll kind of go f inverse of x is 2x minus 1. So now we have y equals x squared. And I did say y is greater than or equal to 0 here, because if I were to look at this function here, x squared is actually not 1-to-1, right? Remember, x squared ends up looking like this as a parabola. That's not 1-to-1. But if I say x value is greater than or equal to 0, now I'm on just half part of it, and so now I've forced it to be 1-to-1. And so now I'm going to find my inverse here. So x equals y squared. Oops, it's kind of a funky square. Okay, how I get rid of a square is I square root. And so I get y inverse is equal to the square root of x. Okay, so if you're going to find your inverse, what you're going to do is you're going to interchange x and y, solve for your new y. So that's inverses, and then we're going to talk about logarithms.